But that gentle star in our sky is an illusion. The sun is not gentle. It is a nuclear furnace, 4.5 million kilometers across, consuming 4 million tons of matter every single second. Today, we're going to do something impossible. We're going to fall into the sun. This is a realistic simulation of what you would see and experience. Based on modern solar physics, Einstein's relativity, and the bizarre behavior of plasma. This journey was created using advanced simulations combined with scientific models to give you the most accurate picture possible. From a distance, millions of kilometers away, the sun looks smooth. It's that glowing yellow disk we all know, but this calm is just an illusion. The sun is a sphere of plasma, state of matter, where gas is heated to such extreme temperatures that electrons are stripped away from their atoms. As you begin your fall, gravity slowly takes hold. At first, nothing feels dramatic. You're floating in the cold vacuum of space. But the sun is already pulling you in, accelerating you to hundreds of thousands of kilometers per hour. Let's take a moment to understand the sheer scale of what you're falling into. The sun contains 99.8% of all the mass in our entire solar system. Every planet, moon, and asteroid is just a tiny fraction of the leftover dust. Over 1 million Earths could fit inside it. Its immense gravity is what holds every planet in its orbit, including ours. And as you fall closer, escape becomes impossible. Not because of a black hole's event horizon, but because the sun is simply too big and its gravity well is too deep. You wouldn't have enough fuel to fight your way back out. You don't just hit the sun, you enter it gradually. The corona is hotter than the surface far below it. Walls of plasma, twisted by magnetic fields, would dance and collapse around you. The sun does not burn like wood. It flows, breathes, and moves like a living thing. As you fall, the intense gravity begins to bend the light around you. Stars behind the sun would seem to distort and shift their positions before fading from view. You are now fully inside the star's domain. Below the corona, we reach what we mistakenly call the surface of the sun. This is the photosphere. It's the layer that produces the visible light we see from Earth. But it isn't solid. It's a boiling, turbulent ocean of plasma. You'd see convection cells, some the size of entire continents on Earth, bubbling up from below. The bright, glowing regions are hotter, plasma rising, while the dark lanes between them are cooler, plasma sinking back down. And then there are the sunspots' dark patches that look like blemishes from afar. Up close, you'd see they are massive magnetic storms, cooler than their surroundings, yet still thousands of degrees hotter than lava. Temperatures here are a consistent 5,500 degrees Celsius. Nothing recognizable could survive. No structures, no familiar matter, not even atoms in their normal state, only a chaotic sea of charged particles. As you fall deeper, the pressure increases at a mind-crushing rate. The sheer weight of the sun's outer layers is pressing down on everything below, and with the pressure, the temperature skyrockets. 10 million degrees. 50 million degrees over 100 million degrees Celsius. The plasma becomes so dense that light itself struggles to escape. Photons. The particles of light are created here, but they can't travel freely. They bounce endlessly from one particle to another, taking thousands, even hundreds of thousands of years to finally reach the surface and escape into space. This region isn't glowing like a lamp. It's blindingly bright from within. Every point in space is a source of intense light. Welcome to the radiative zone. Here, energy moves not by boiling convection, but by slow, agonizing radiation. Photons are born from the fusion in the core and begin a random walk, colliding with particles over and over again. There is no clear direction, no up or down, just an endless, uniform fog of energy. If you could somehow see inside this zone, which is impossibly, would feel like being trapped inside a star-sized cloud made of pure light and heat. This is where the sunlight that warms your face on a summer day is born. But the light you feel today began its journey out of the sun's interior long before human civilization existed. Finally, we reach the core, the very heart of the sun. Here, conditions are almost beyond comprehension. Temperatures exceed 15 million degrees Celsius. The pressure is over 200 billion times that of Earth's atmosphere. The plasma is denser than lead. In this inferno, the universe's most powerful process takes place. Nuclear fusion, hydrogen nuclei, simple protons are slammed together with such unimaginable force that they overcome their natural repulsion and fuse together. Hydrogen becomes helium. In that process, a tiny fraction of their mass is converted directly into a tremendous amount of energy. This is what powers the sun. There is no flame, there is no combustion, there is only the continuous, silent act of nuclear creation. So, what happens to you in the end? You do not burn. You are not crushed. You are simply unmade. Your atoms were stripped apart in the corona. Your fundamental particles, protons, neutrons, electrons are scattered into the dense plasma of the sun's interior. Your mass becomes part of the star itself. For a brief, fleeting moment, the particles that once made up your body might participate in the same fusion reactions that power the entire solar system. Some of that energy, born from what was once you, may one day escape the sun and travel for 8 minutes across space to reach Earth as a ray of sunlight. As we pull back, leaving the core, the radiative zone, the photosphere, and finally the corona, we see the sun for what it is. A star without mercy. It is not evil, it is not angry, it simply obeys the laws of physics. It gives life to our world without caring about what it destroys in its heart. But every sunrise we see is powered by forces that would erase us from existence in an instant. And yet, here we are, orbiting safely, at just the right distance. Our entire world balanced on the gentle edge of a nuclear abyss. The sun does not burn, it transforms. Thank you for joining this incredible journey into our star. If you found this cosmic perspective as fascinating as I do, consider subscribing and turning on notifications for more explorations into the universe. See you in the next one.